Hello, welcome to in this DMS class. Now today we'll see how to show equivalence between two statement formula by without using truth table. Whenever without using truth table term come ahead, at that time we have to use standard laws. Okay, that laws I have just separated in by section A, section B, and section C. Okay. So in section A, we are going to see the laws related to conjunction, disjunction, negation. Okay. So with respect to all these basic connectives, we'll see one by one. P is atomic proposition. Disjunction, true. If you find result of this compound proposition, definitely it becomes true. If you find the truth table, or if you see that all these things with the help of truth table, definitely you get same answer. So P or T equivalence with true, P and F equivalence with F. This particular law is known as domination law. Okay. By practicing only, that all laws will be keep in your mind. Second, identity law. If any atomic proposition ending with true, then we'll get result as a P. If any atom proposition oring with F will get result as a P. This particular law is known as identity law. Third one, idempotent. P and P always equivalence with P. P or P always equivalence with P. Okay, if we do the ANDing or ORing operation in between same atom proposition, we'll get result as a that variable itself. Fourth, A, De Morgan's law. What De Morgan's law indicating? If negation sign present outside the bracket and if we take inside the bracket, then what exactly happens? Now see, P or Q, that all things present inside the bracket and outside the bracket negation sign is there. If that negation sign, if I want to take inside the bracket, then definitely this negation will be applied to individual atom proposition. So negation P, negation Q, but whatever sign is present inside the bracket, that will become change. If sign is or, then definitely it becomes and. So that particular law is De Morgan's law. Now see, second example, negation P and Q, negation of whole this bracket. If negation enter inside this bracket, negation P, definitely and becomes or. Okay, that change will be applicable only for and or. Keep in mind. The next, double negation law. Negation present outside the bracket and inside the bracket again negation of P. Then negation will be get cancelled. Then here we'll get P. Okay, so here we have seen domination law, identity law, idempotent law, De Morgan's law, and double negation law. Okay. If we ORing with P and its negation, individual negation, definitely result is true. If ending with atomic proposition P and its individual negation, will get result as a false. This law is known as negation law. Commutative law means what? If you find result P and Q, and if you find result Q and P, both results are same. Okay, means we are keeping sign as it is, just we are interchanging the atom proportion. Okay, then meaning will not get affected, right? This law is known as commutative law. Associative law. For this law, we have to take care is what? We have to just modify the things is what? Here we have to check whether inside the bracket and outside the bracket signs are same or not. That is your first thing. Okay, and inside the bracket and outside the bracket, while considering atom proportion, all these three atom proportions are different. That two things we have to keep in mind while applying the associative law. First thing is what? Inside the bracket and outside the bracket signs are same, and all the atomic proposition which is present inside the bracket and outside the bracket, all these three atomic propositions are different. Okay. Now see, P and Q and R. Here inside the bracket sign is what, and outside the bracket sign is R. It means we can combine anything inside a bracket, and if we can put outside anything outside the bracket, meaning will not get affected. Now see, P and Q and R equivalence with. Here I am keeping P outside and we are taking Q and R inside, meaning will not get affected. So this particular law nothing but associative law. Similarly, P or Q or R, I can keep P as outside and I can keep Q and R it is inside. But sign we are keeping as it is, meaning will not get changed. This is law nothing but associative. Distributive, similar, inside the bracket, outside the bracket, atomic proportions are different. Here see, P, Q, R are different. But main thing is what? For associative, we have seen inside the bracket and outside the bracket signs are same. But here, inside the bracket and outside the bracket signs must be different. If it happens, then definitely we can apply distributive law. Now see the first example. Here inside the bracket sign is and outside the bracket sign is disjunction, that is nothing but or. How we can apply distributive law? Whatever atomic proposition present outside the bracket and whatever connective present outside the bracket, by using these two, we can enter inside the bracket. Is that clear? So P or Q will get, then P or R will get, and in between we are using common sign as a conjunction. So this is the result of this left hand side and result of this right hand side definitely equal. Is that clear? Similarly, P and this thing present outside the bracket, if we put inside the bracket, P and Q will get, then P and R will get, and common sign is what? Disjunction. The result of this left hand side and the result of this right hand side definitely same. That is nothing but distributive law. Sometimes confusion may occur in associative law and distributive law. Only simple thing is what? While applying associative law, we have to take care is what? Inside the bracket and outside the bracket sign must be same. And while applying distributive law, inside the bracket and outside the bracket sign must be different. Is that clear? Then last one, absorption law. Here condition is what? Inside the bracket and outside the bracket signs are always different, but whatever atomic proposition present outside the bracket, same variable must be present inside the bracket. Is that clear? If it happens, then definitely answer will be P as it is. Okay, now see the here P or P and Q. Inside the bracket, outside the bracket signs are same. Then whatever atomic proportion present outside the bracket, same atomic proportion present inside the bracket. Then answer will be P. Okay, so this is law nothing but absorption law. Just now we have seen domination law, identity law, independent law, De Morgan's law, negation law, double negation law, commutative law, associative law, distributive law, and last one, absorption law. So in first section, we have seen the laws related to conjunction, disjunction, and negation. Now in second standard law, I am just splitting in B, conditional law, laws related to condition connective. Okay. P conditional Q always equivalence with. See here, I'm just simplifying. P conditional Q always equivalence with. Here, what is your first atom proposition? P. Will take negation of that. What is your second atom proposition? Q. Will take as it is Q. And in between these two, we are using always disjunction. Means conditional sign is there. When your condition sign is present between this any atom proposition, always we can simplify by using condition law as it is nothing but first variables negation, second variable as it is. In between these two, we are using disjunction sign. Hope all of it is clear. Then last section, laws related to bicondition law. If P by condition Q is there, then by applying by condition law, how it becomes simplified? P conditional Q and Q conditional P. Now see, P by conditional Q, it means P conditional Q, Q conditional P, and in between these two brackets, we are using conjunction. If you find truth table of this bracket and right hand side, definitely will get same result. Now see, in 2B, we have seen condition law. So can we apply condition law over here? Because by condition law get replaced with condition. Can we apply condition law over here? Yes. How? P conditional Q. How it simplify? First part P will take negation. Second part Q as it is. Similarly for second bracket, first part is Q will take negation. Second part as it is in between these two part. Okay. So this is all about standard laws. Also we can simplify by condition law. P by condition Q is equivalence with P and Q or negation P and negation Q. I can use these two statement formula as per our requirement. Okay.